Hi friends, welcome back to Hobby Plus. Today our subject is Arduino isolation from the output circuit or heavy ampere circuit, heavy voltage also. So we make this video for that. First of all, we try to control the MOSFET from the Arduino. So we make a program and we get the output from the port A0, that is your pulse, that is 5-volt pulse. When you put here your 5-volt pulse, you have to calculate the lead capacity of the optocoupler, and if your lead can drive 5-volt, then you can use it. If not, then how to control this pulse, I make a video just now and you can get this in my channel, how to drive your optocoupler. So you can do this. When you make this pulse and drive the optocoupler, then optocoupler amplify the pulse something this circuit. But we have to understand what is the gate voltage we require and what is the ampere of this optocoupler. In that number, we know 50 milliamps maximum current flow through this transistor. If you have any doubt, you can see the datasheet. So we have to calculate the rail of this collector. When we get 50 milliamps, then what is the resistance network we should know? We know that, because if you don't know that, then you just watch my resistance divider video. So we have to put here a resistance. It is necessary because 24 volt, that 24 volt you can drive through this optocoupler, but if there is 2 ampere or 5 ampere, you cannot drive the optocoupler with 5 ampere. So you have to need this network for 50 milli, or you goes to 30 milliampere. 30 milliampere good enough for drive your MOSFET. And put here, if it is your gate source voltage is 20 plus minus 20 volt, then you make here plus minus 20 volt because it is 24 volt. That means in this network you also calculate ampere and voltage. You know that. If not, watch my channel, you can get it. After that, when you put this voltage through this network in the gate of the MOSFET, and your signal, you can get your signal from here because you drive the optocoupler from this signal. So when you use PWM, then you can dim or dip this LED through this circuit. That is not our goal. Our goal is how to isolate and how to measure the current and voltage of the output of this circuit. If you do this, your Arduino is absolutely isolated. For that, I have to tell you, when you measure your ampere, that is your ampere transformer, you can get measure from this transformer. You can measure your ampere from this transformer, right? So your turn must be 1. Primary turn must be 1. And secondary turn you have to calculate. Suppose that is your 5 ampere power supply, 24 volt 5 ampere. So maximum 5 ampere when through this lead goes to ground, that means this rails also 5 ampere. So you get a high voltage here, and that should support by the Arduino. The maximum 5 ampere through this path, so you get a voltage that is also a maximum 5 volt. So you have to calculate the ratio, and when you through this, actually if you short circuit this circuit, then maximum ampere through this, or if your power supply is 5 ampere, that means 24 volt 5 ampere, that means you can calculate your resistance. So you put here a resistance and through this transformer you can pass it, so you can get maximum voltage. Now you can calculate your isolation transformer and put here, if you get your MOSFET drive 5 ampere, then maximum voltage come here, and that is you show your display, that is 5 ampere current pass through this route. That is the simple way, isolate and read. But don't forget, if you have a 24 volt voltage, 24 volt, and you have a 0.000000 ampere, what is the meaning of that? There is no meaning at all. That means voltage and ampere always make together. There is no voltage, that means there is no current. There is no current, that means there is no voltage. It is always true. So when you measure your current, you also get voltage. Read the voltage, show the current. When you show the voltage, you can do this, no problem at all. And opposite also you can do. You make a transformer for that. Here is primary turn is 1, but here is maximum turn you have to, because you do not waste your current through this way. So why I make this resistance network 470k and 47 ohms. So it is very little voltage you can get from here, but you have a trouble. I don't know how can you calculate this voltage. I get a little voltage here, suppose 3 volt, but I don't understand what is the maximum voltage. I show you. Look here, there is the formula. Your R1, your R2. R2 is your lower arm and R1 is your upper arm. Like as this. 470 is upper arm and 47 ohms is your lower arm. What is the voltage? How can you calculate the voltage? V divided by R plus R1 plus R2. R1 plus R2 into R2. R2 is your lower arm. So that is the value of 400. This value is 100. So you can get V by 4. That is your output voltage 3. That is your output voltage. So V by 4 is equal to 3. That means V is equal to 12. It is easy and simple. So when you get here a voltage 3 volt, then easily you can calculate this value. But remember that you have to put here minimum current. Minimum current can through this rail or this network, because we have to protect our current we want to drive the lead, do not use any misuse any current through this way. So that resistance must be higher. And also you can do one thing, I already told you, you replace this resistance by a transformer which also get you a voltage. You read this, I think you know the ratio, primary turn and secondary turn ratio. If you put here, you can easily do same thing, just in opposite. You have to replace this resistance network through this transformer, but one thing you have to remember, in that case you have to use a transformer where is high impedance resistance here, high impedance coil you have to put here, and low impedance output you must use here. So that's why I want to explain why we tell that, why I am telling that, because in the transformer we cannot lose any power which is not necessary for our calculation, so we cannot lose it. So high turn transformer put here, and low turn output also there, so you get a voltage. And do same thing like as that, you can do it, that is also isolate your Arduino from this circuit. And resistance network also good enough to do this. So you have to put here a resistance network, no problem at all. It is always safe and secure, do not forget that. And remember that that is your ground one and that is your ground, both are not in same. This ground and this ground are same, but this ground is not exactly equal with it, so do not attach both ground in the same track. I think you understand that how can you calculate your voltage, how can you measure your voltage, and how can you measure your ampere, something like this circuit. If you think it is helpful, please write me in my comment box, yes it is helpful, or if you have any doubt, please tell me that also. I will try to clear your doubt, and you know what to do, please do this. Thank you for watching.